let's start by looking at some examples of linear equations, especially examples that are not in the typical format of what you expect with linear equations. So for example, negative 4 over x plus 4 equals negative 3 over x plus 6. Now this does not look like a linear equation. So one way of solving this is to find the LCD of all the denominators. So here that will be the product of x plus 4 times x plus 6. And then we'll multiply all of our terms by that LCD. So on the left side, the x plus 4's cancel, and we're left with negative 4 times x plus 6. On the right-hand side, we have negative 3 times the x plus 6's cancel, and we're left with negative 3 times x plus 4. So we would have gotten the same thing if we had cross-multiplied and set both sides equal, because this is a proportion. So that would have been an alternate way that you could have solved this problem. So right now, we will continue by distributing. So negative 4 times x, negative 4x. Negative 4 times 6 is negative 24. Negative 3 times x, negative 3x. Negative 3 times 4 is negative 12. Okay, and now you can see this is a linear equation. We don't have any exponents. It's just we just have the linear terms x, and then we have constant terms. So in order to solve this, let's get our x terms, our linear terms, on one side of the equal sign and our constants on the other side. So I'm going to start by adding 3x to both sides. We'll get negative x minus 24 equals negative 12. I'm going to add 24 to both sides. I have negative x equals 12, but we don't want negative x, we want what x is. So let's divide both sides by negative 1, and x is negative 12. So one thing that we do need to check, especially when we are starting out with a rational equation, even if it turns out to be just a linear equation, is we need to make sure that our answer, in this case, negative 12, does not make either or any of the denominators 0. So if I put negative 12 in for x in the first denominator, is negative 12 plus 4 equal to 0? No. It doesn't matter whether or not we calculate that negative 12 plus 4 is negative 8. We just know it's not equal to 0. And we're trying to avoid that because division by 0 is not defined. What about trying negative 12 in our second denominator? Is negative 12 plus 6 equal to 0? No. So since negative 12 does not make either denominator 0, negative 12 is our solution. Okay, let's look at another problem. X over x minus 2 plus 3 equals 2 over x minus 2. So here we see two rational terms, and then we see plus 3, but we can write the 3 as a rational expression by putting it over 1. So in order to get rid of the fractions here, to get rid of the denominators, let's find the LCD. So we only have basically one term in the denominator. We have the x minus 2. Technically, we also have 1, but if I did x minus 2 times 1, I just get x minus 2. So my LCD is x minus 2. Now we're going to multiply all of our terms, all three of them, by that LCD, by x minus 2. When I do that with the first term, the x minus 2's cancel out. Technically, it leaves 1s, and I'm left with just x in my numerator, which is just x. Plus 3 times x minus 2, and I'll wait and distribute on the next step. And it's technically it's over 1, but anything over 1 is the same as just 3 times x minus 2. Sorry, not anything over 1, but this 3 times x minus 2 over 1 is the same as 3 times x minus 2. And then the x minus 2's cancel on the right-hand side, and we are left with 2. Okay, so now let's do the distributing on the left-hand side. So I have x plus 3 times x is 3x. 3 times negative 2 is negative 6, and that equals 2. Let's combine our like terms on the left. We've got x plus 3x, which is 4x, minus 6 equals 2. Let's move the 6 to the right-hand side by adding it to both sides. 4x equals 8. Divide both sides by 4, and x equals 2. So x equals 2 is our potential solution, but remember, we need to check. Does x equal 2 make it denominator 0? So if I put x equals 2 into a denominator like x minus 2, does 2 minus 2 equal 0? Yes. That means x minus 2 is not a solution. Technically, it's considered an extraneous solution. And because that was our only potential solution and it's extraneous, here we have no solution, which you may sometimes see written as the null set or the empty set. But this problem has no solution. No value of x will make this equation true. Okay, so now we have the equation s equals a over 1 minus r. And instead of solving and getting a numerical answer, here we are going to solve this for r, which means that we are going to rearrange this equation to get r by itself on one side of the equal sign. We want to find out what r equals. And we will have s and a, like those variables, in our answer. Okay, so we can still start by finding the LCD. So the left-hand side is over 1, the right-hand side is over 1 minus r. Our LCD is 1 minus r. We're going to multiply both sides by that LCD, the left-hand side and the right-hand side. When I multiply the left-hand side by 1 minus r, I get s times 1 minus r. When I multiply the right-hand side by 1 minus r, the 1 minus r's cancel out, and I'm left with a. So remember, technically when terms cancel out, we're left with 1's. So I just have a over 1, which is a. Let's distribute. S times 1 is s. S times negative r is negative sr, and that equals a. And remember, we're looking for r. We need to get r by itself. So we need to get this term with the r in it by itself. Let's subtract the s term that's in front of it from both sides. And that will leave me with negative sr equals a minus s. Okay, we're almost there. To get r by itself on the left-hand side, let's divide both sides by negative s. So on the left-hand side, the negative s's cancel, and we're left with r. On the right-hand side, a minus s over negative s is technically a correct answer, but often you'll see it written in other forms because having that negative in the denominator is not necessarily common practice. It's not wrong, it's just not what you would commonly see as an answer choice. So I could get rid of the negative in the numerator by moving it up. Get rid of the negative in the denominator by moving it up to the numerator. So I could consider this to be the opposite of a minus s over positive s. So here, let's distribute the negative in the numerator. Negative a times negative, the opposite of negative s, which is positive s. And that's over s. That's your answer. But because of that negative out in front, often you'll see it so that the numerator is rearranged and that r is written as s minus a over s. But that first expression that we got, r equals a minus s over negative s, is correct, just as well as r equals s minus a over s. they are the same or equivalent answers. Okay, let's look at a word problem. Going into the final exam, which will count as 2/3 of the final grade, Mike has test scores of 86, 80, 84, and 90. What minimum score does Mike need on the final in order to earn a B, which requires an average score of 80? Okay, so we have a final exam grade, which we're trying to figure out, and that will count as 2/3 of the final grade. Mike has scored 86, 80, 84, and 90 on his tests, and we want to see what is needed for that final exam to make a score of 80 in the class. So 2/3 x, 2/3 times the final exam, because the final exam is worth 2/3 of the final grade. And here you really should be taking note or indicating what your variable is representing. So here x is the grade on the final exam, and you can do that by writing out what x is. Sometimes in problems you can do that by just writing the x above the term it's representing, but you should take note of what your variable is representing. So 2/3 x plus, okay, so if 2/3 of the grade is the final exam, that means we've got 1/3 of the grade left, which is made up of the average of his tests. So 1/3 times, and to find the average or the mean of his test scores, we will add up all the test scores. So 86 plus 80 plus 84 plus 90, and we've got 4 tests, so we divide that sum by 4. That will give us the average, and we want to know what x will be, what the final exam will be, in order to make this expression equal 80. Okay, so in my next line, what I'm going to do is just calculate what the average is. I'm going to figure out what 86 plus 80 plus 84 plus 90 over 4 is. So 2/3 x plus 1/3 of 85 equals 80. Okay, so now I could leave everything with fractions, but I could use what we were doing earlier in examples and get rid of my fractions by identifying my LCD. And here, my only denominators are 3's, so that's my LCD. And I could multiply everything by that 3. And when we do this, you're going to see the fractions go away if we do it correctly. So when I multiply 3 times 2/3 x, the 3's cancel. We're left with 2x. When I multiply 3 times 1/3 times 85, the 3's cancel, and I'm left with 1 times 85, or 85. And on the right-hand side, I have 3 times 80, which is 240. Okay, this is why this is in the linear example section, because this is now a linear equation. So to solve this equation for x, let's subtract 85 from both sides. We get 2x equals 155. Divide both sides by 2, and x is 77.5. So Mike needs to get a 77.5 on his final exam in order to earn an average out of an 80. Now, if this were a type of class where you could not get decimals as exam grades, you would have to say that Mike would need a 78 on his final exam. So depending upon the context of the problem, either a 77.5 or a 78 would be the final exam grade needed. Okay, let's look at one more word problem. The perimeter of a rectangle is 42 meters. Find its length and width if the length is twice the width. Okay, in a problem like this, I would start off by trying to picture the problem and drawing a rectangle. So here's my rectangle. Okay, we know that the perimeter is 42. We know that the length is twice the width. So the smaller side is the width. I'm going to label the vertical side as my width. And I'm going to make that variable w. And we know that the length, which will be the horizontal side, is twice my width. So 2w. We know it's a rectangle, so we know we have w and then 2w on the other two sides. Perimeter is the sum of all the sides. So I could write this equation, or start off with the expression w plus 2w plus w plus 2w, and we know that that needs to add up to 42, which is our perimeter. You could have used a different formula for perimeter if you knew one, but this one works. Now if I simplify my left-hand side, w plus 2w plus w plus 2w, I have 6w equals 42. Divide both sides by 6, and w equals 7. Remember, like I can go back to my picture of my rectangle, and I know that this width, which had length w, is 7 meters. And my length, which is 2w, is 2 times 7, or 14 meters. So I could label it on the picture. I could also write out the expressions. The width equals 7 meters. The length equals 2 times 7 meters, or 14 meters.